Hi everyone, we're starting on Unit 7 today of trigonometric functions. Starting with Lesson 7.1, compound angle formulas. Compound angle formulas are also known as addition formula because they contain two given angles, let's say A and B. And the following formula holds true. Cos of A plus B does not equal to cos of whatever value A plus B is, but instead there's an equation. Cos of A plus B equals to cos A times cos B minus sin A times sin B. When you're doing the the compound angle formula for cos, make sure you pay attention to the sign, because the sign on one side of the equation is reversed on the other side of the equation. So in this case, we had A plus B, but on the other side, we had a subtraction sign. Cos of A minus B equals cos A times cos B plus sin A times sin B. Sin of A plus B equals to sin A times cos B plus cos A times sin B. Sin of A minus B equals to sin A times cos B minus cos A times sin B. So in the case of sine, if we have addition on the left side of the equation, then on the right side of the equation we also have addition. If we have subtraction on the left side of the equation, and on the right side, we'll also have subtraction. So the signs are not reversed. Let's take a look at example 1 from your learning resources. Expand sine of theta plus alpha. We have to refer back to our compound angle formula. The formula states sine of A plus B equals to sine A times sine B plus cos A times cos B. So in this case, A would be theta and B would be alpha. We simply replace them and we will get sine of theta plus alpha equals to sine theta times cos alpha plus cos theta times sine alpha. Let's take a look at example 2 from our learning resources. Simplify cos 3 theta times cos theta minus sine 3 theta times sine theta. In this case, we have to reverse the compound angle formula. We know cos A cos B minus sine A sine B equals to cos A plus B. In this case, A equals 3 theta and B is theta. So then we get cos 3 theta plus theta. The final answer is cos 4 theta. Let's take a look at example 3 from our learning resources. Without using a calculator, show that cos of 13 pi over 12 equals to negative square root of 6 minus square root of 2 over 4. First thing we have to do is break up the cos into A and B. In this case, A will be pi over 4 and B will be 5 pi over 6. Some of you might be confused by how I did this, so I'll break it into steps. We have cos of 13 pi over 12. We can write it as cos of 3 pi over 12 plus 10 pi over 12 because 3 pi plus 10 pi equals to 13. 3 pi over 12 is the same thing as pi over 4, and 10 pi over 12 is the same thing as 5 pi over 6. We do this because now we have cos of A plus B. In this case, A is pi over 4 and B is 5 pi over 6. And it's very easy to evaluate cos of pi over 4 and cos of 5 pi over 6. So if we use the compound angle formula, that will give us cos of pi over 4 times cos of 5 pi over 6 minus sine of pi over 4 times sine of 5 pi over 6. Cos of pi over 4 is the same thing as 1 over square root of 2, which is the same thing as square root of 2 over 2. Cos of 5 pi over 6 is negative square root of 3 over 2. Sine of pi over 4 is square root of 2 over 2, and sine of 5 pi over 6 is 1 over 2. So if we do all the algebra, that will give us the final answer of negative square root of 6 minus square root of 2 over 4. And that's what we wanted from the original equation. And that's the end of this lecture. Thank you guys for watching. Remember to check out your activity video as well as your assignment and upload them for your teacher to mark. And I'll see you guys next time.